So you've seen the power that this layout has, and I suppose what I'd like to share with you is what makes it possible. The thing to stress, I suppose, is they're all standard components. You can buy these things from manufacturers. I'm no electronics engineer. They're just components that I've plugged together. My knowledge is soldering ordinary wires together and making these things work. What I'd like to do is take you on a sort of guided tour around all the components and explain how they all interoperate, because it's quite simple actually. So let me show you down here on this board is one of a number of boards that I have on this layout, and I'm going to explain each of the areas and what they're about. Up here is one of Digitrax's boosters. I have one of these that acts as a command station that controls everything on my layout. It's the thing that provides the power across the whole layout, and it also provides the digital signals to control everything. On my layout, I've actually got the command station, and I have a whole set of things called boosters. This gives me the ability to have 5 or 6 areas around the layout that all have individual power, enough power to drive the trains in their area, but they're still all controlled from one central command station. If you've got a smaller layout, you probably do not need boosters. You can probably run anything between 5 and 10 trains on one command station. If you want to run more, you might want to segment your layout and put boosters in accordingly. Going on down, from the booster here, we have a thing called a device or a board called a PM42. This is a power regulator. It's a very important function that it provides in that it will allow, if a short circuit occurs anywhere on the layout, it will stop the whole booster district being shut down. They're not absolutely necessary, but as I'll demonstrate in a moment, I can short circuit or have a derailment on one track and still have other trains operating. So this is a practical demonstration about how the PM42 works. There are 4 tracks here, 2 protected by one PM42 zone and 2 another. If I create a short circuit on the track with the train on it, you'll notice that it immediately cuts out power and stops the train. You hear that clicking sound. That's telling you that there is a short circuit on the track and that the power is being cut off. That's good news for the engine, the motor, the chip and anything else that's connected to the track. If I then take that short circuit away and put it on the other track, notice how this train can continue to still run, but the other circuit is now being isolated. And that's the power of the PM42. After the PM42, the output of the power then goes through devices called the BDL168. Their function is to provide circuit detection around the layout. If you're not going to use computer control, it's probably unlikely that you will need them. But I use them, and they're probably one of the most important parts of my layout, because this device has 16 detection zones that as soon as, if one of them is occupied, this device understands that and reports it out over LocoNet. So each BDL device can monitor 16 sections of track. And on this board, I have 2 of them monitoring 32 sections. Coming back to the LocoNet, if you notice, everything on this board is connected by this grey wire. It runs through everything. And the really valuable part about that is that LocoNet is connected to everything on the layout. The BDL168s, when they detect an occupancy in a particular zone of track, they send an occupancy message out. Any device on the network that's tuned to listen to those things, such as the computer control software or the signalling system, can receive that message, interpret it, and make decisions based on that. So this is a practical demonstration of how the BDL168 works. As you might remember, I told you that this device measured track circuit occupancy around the layout. I have an engine here that isn't running, but if I put it on the track, you'll notice that the lights come on. The LEDs at the far end of the room are illuminated. When I take it off, they go off. On again. And finally, if I take it off, the occupancy goes out. For me, it's really important for the computer and the signalling control systems, who both look for occupancy as a fundamental control mechanism for making sure that trains operate in a safe manner. On this board, we have the other 2 fundamental devices on the layout. This is the DS54. It's a device that controls 4 point motors. And in addition, as you remember I talked about earlier about LocoNet, it gives the feedback onto LocoNet that the points have actually been changed. I can control these points using LocoNet messages from any handheld throttle or the computer or even terminal control boards. They all send out instructions to the DS54 for it to change its points. As you can see on the numbering here, this particular DS54 controls points in the range 625 to 628. This is demonstrating the DS54 feedback messages. The camera is focused on the display boards at the far end of the room, and if I change point 204 from closed to thrown, you'll see that the display board system sees that message being sent out and changes its display accordingly. Once again, I take the point back to closed, the lights change, back to thrown. Over here, this signal board controls 10 signals, and when it gets appropriate messages through, it knows how to interpret those and says, I've got to change my signal from red or from green to red or from red to green. And it in turn sends out a signal message to other signal boards to tell them that its signal, maybe signal 200, has changed its colour from green to red, and the signal behind it goes from red to yellow, and the one behind that then knows to then go from yellow to green. And you program these boards via a PC interface over LocoNet. So here we now see a broader display of how the BDL168 occupancy messages and the DS54 point feedback messages affect things like the signalling system. The path is currently clear for red 12. If I occupy the track down below, if I put an occupancy down there, the red 12 has gone to red because the track ahead is occupied. If I take the occupancy off, the signal will revert back to green. If I change point 204 from the path that it's currently set, which is allowing red 12 to progress through the junction, to black 28, you'll see the point indicators moving over as you've seen before, but also the signals will also change their relative aspects from red to green and green to red respectively. Back to thrown, the signals revert. Once again to closed, and that's the power of this system. So here we have the two signals we showed up on the control board. The one on the left has the clear path through, the points, and the route ahead is clean. The green light is showing. If I put the same shunter on this track here in front of it, the track is immediately occupied. The BDL168 that supplies the power to this section of track sends out an occupancy message to all devices connected to LocoNet. The signal control board that's looking after that particular signal mast listens to it, works out that it's an important message for it, and then changes the aspect of the signal in front of the occupancy that's just been put in place and sends out a message to the other devices. And that in essence describes how the signalling system